Hey guys, this is 5-2 polynomials, linear factors, and zeros. And we're going to go through these set of notes, and then hopefully by the time we're done, you'll know what we're doing. So we have a little review here. It says number 1 says cross out the expression that does not have x to the fourth as a factor. That means that the powers have to be 4 or greater. So if x to the fourth is a factor, then the exponents have to be 4 or greater. So x to the fifth, obviously that exponent is 5, so it's greater than 4, which means that x to the fourth would be a factor. 2x to the third, that one's not less than or equal to 4, so that one won't work. Okay, then the next one we have x to the third times x times y. We actually have to simplify that first. That's x to the fourth times y, so it does have a factor of x to the fourth, so it's a keeper. And then the next one is going to be 9x to the second because you square both the 3 and the x to the second. Just kidding. How about x to the fourth? So it also has a factor of x to the fourth there. The second step says circle the factor tree that shows the prime factorization of 14x squared. So it's actually going to be this very first one. We're going to do the prime factorization of 14. 14 is 2 times 7, so those are the prime factors. And then you're going to do the variable parts in a separate step. And so I have x squared is x times x. So 2 times 7 times x would be the prime factorization. Okay, so for part 3 it says write the letters of the points that describe each turning point in the intercept. So we talked about turning points being where literally the graph turns. And so B and E would be my turning points. And they're also where you find what's called the relative maximum or the relative minimum. Relative just means any. So if I have any maximum point where it's like a bump, okay, any turning point is a max or min. It just depends on whether it's the greatest or not. So B is going to be a maximum, and the relative minimum is the other turning point, which is E down at the bottom. The the x-intercepts, we have 3 of them, 3 places it crosses the x-axis at A, C, and F. And the y-intercept, there's one of those. And that's D down there. It says, number 4 says place a check mark in the sentence that shows a correct use of the word turning point. Turning point means a change in direction. Something's happening. And if it doesn't, we're going to put an X. The turning point in a story was when the hero chose the book instead of the sword. So they're doing something different. The actions are changing, so that would be an example. The function has a turning point where x is 17. That could happen as well. It may not be on the x-axis, but it has an x-coordinate of 17. A function has a turning point when it crosses the x-axis. Well, this one crossed the x-axis at 3 places and none of them were turning points, so that's not true. Okay, on the next page we've got problem 1 there. It says we're going to write a polynomial in factored form. So we're going to follow the steps to do this, and we've done this before. It says what is the factored form of x to the third minus x squared minus 12x? The first thing we always do is we're going to look for a common monomial and see if that's our very first factor. And that just means something that all of the terms have in common. And they all have at least one x. So that's what they did right here, is they pulled out an x. When I do that, what's left over is x squared minus x minus 12. So we're going to focus on this trinomial here, x squared minus x minus 12, and we're going to factor that as well. It says complete the factor table, then circle the pair of factors that have a sum equal to -1. So we want factors of -12 that give us a sum of -1. So factors of -12, 1 and -12, -1 and 12, 2 and -6, -2 and 6, 3 and -4, and -3 and 4. Those all give me a product of -12. And then the sum, 1 plus -12 is -11, -1 plus 12 is 11, 2 plus -6 is -4, -2 plus 6 is 4, 3 plus -4 is -1, and -3 plus 4 is 1. So we do have a pair that gives us a sum of -1, and that's 3 and -4. So we're going to use those to factor. Again, we took our polynomial, we already factored out an x, and that gave us x squared minus 1x minus 12. So we still have that x factor out in the front. Our trinomial in here is now going to be factored with an x in each term, or each factor, and then you take whatever numbers that you got that worked for your factor sum chart there, and we're going to put those in. So plus 3 and minus 4, and that's our factored form. Okay, example 2, it says finding zeros of a polynomial. So in the last problem, we took a polynomial and we factored it. We put it into factor form, and it had 3 factors. This is one that's slightly different, but it's still in factored form, where the polynomial would be factored into x, x minus 3, and x plus 5. So it wants us to graph the function. It says use the zero product property to find the value of x in each factor. So all it wants to do is take each of these factors, the x, and set it equal to 0. The x minus 3 equal to 0, and the x plus 5 equal to 0, and then we're going to solve for x for each one of those. So obviously x equals 0 is still just going to be x equals 0. If you add 3 to both sides, you're going to get x equals positive 3, and if you subtract 5, you're going to get x equals negative 5. So these are your zeros, and they're called zeros because those are the places where y equals 0 on the coordinate plane. So we had, when we solved this, our zeros are 0, 3, and negative 5. That just means those are our solutions, what we solved for x. And what we would do with those is we would put them on the x-coordinate, or the x-axis of the coordinate plane. So we have a 0, we have a 3, and a negative 5. So I know that my polynomial is going to go through those points. The graph of the function crosses the x-axis at -5, 0, 0, 0, and 3, 0. Now it says, now graph the function. Well, what do we know about this? If I multiplied that all together, my first term would be y equals x cubed. So I know it's going to be positive. That means it's going to end in the up direction. It's going to go from down on the left to up on the right. And then I'm going to have 2 turning points. So just a guesstimation, it's going to look something like this. And then if we wanted to, we could use Desmos to get a little more accurate about the top and the bottom, or the highest values and the lowest values. Alright, so we can graph this, and we're going to be able to tell where the maximum and minimum values are. So we have y equals x times x minus 3. I think it was x minus 3. Let me double check real quick. Yeah, x minus 3 and x plus 5. So you don't even have to multiply it out to put in there. You can just put it as is. If I could do it right. There we go. And so that's my polynomial. It just happens to be in factored form, and we can't see it all. So what I want to do is I want to zoom out a bunch so I can see where my maximum values and my minimum values are. And I've got a max at negative 336, it looks like, and 1.67 and negative 14.18. So when I graph those, I'm going to kind of guess that my max is at 36 and my minimum is about negative 15. So to graph that on here, and I already had my intercept points, we're at negative 5 and 0 and 3. And then I had a max at 36. I'm going to guess that's about, let's see, negative 336. It's right in there somewhere. And that's a maximum. And then I have a minimum at about negative 14. So somewhere in there. And then here's my actual graph. So we can get a little more accurate that way. Still had it the same direction before, we just didn't have accurate maximum and minimums. Alright, we're going to try this last one here, the theorem, the factor theorem. The expression x minus a is a factor of a polynomial if and only if the value a is a zero of the related polynomial. So let's say that's our factor, and so we have x minus a equals 0. So if I solve for x, I get x equals a by bringing a to the right side. So that would mean that a was a zero of my polynomial. It wants us to circle the zeros of this given polynomial. All we do is set each factor equal to 0 and solve. And those will be our zeros. So if I set x minus 2 equal to 0, then x is going to equal 2. If I set x plus 3 equal to 0, x is going to equal negative 3. And if I set x plus 4 equal to 0, x is going to equal negative 4. So those are my zeros, 2, negative 3, and negative 4. Okay, number 13, a polynomial equation, q of x. So that's supposed to represent our equation. So if we take an equation or a polynomial and we set it equal to 0, it says it has a solution of negative 2. It says cross out the statement that is not true. So that means at some point, whatever, we don't even really know what q of x is, but we know that it has a solution of 2. So along the way in our factors, we ended up with x equals 2. If you go backwards from that, so what did that previous step look like? You would subtract 2 and you'd have a factor of x minus 2. That's part of your polynomial, whatever, polynomial q. So we want to cross out the things that are not true. So if the solution is negative 2, it says one of the roots of the equation is negative 2. Well, that's true. A root and a 0 was negative 2 and plus 2. Let's fix that. The solution was negative 2, and so the factor is x plus 2. So since the root is negative 2, that's the same as a 0. That's a keeper. There is an x-intercept on the graph of the equation at x equals negative 2. That's true. Any of the zeros are going to be our x-intercepts. And a factor of the polynomial is x minus 2. Well, we found that that wasn't, we don't know for sure. It could be, but we know that x plus 2 is definitely 1. So we're not sure about that one. We'll cross that one out. Problem number 3, writing a polynomial function from its zeros. So how do we go about that? It says, what is a quadratic polynomial function with zeros 3 and negative 3? So they kind of went through it on already, and they just want to know what kind of things we did to do this problem. We have the polynomial is found below. Use one of the reasons in the blue box to justify each step. So the first thing is we have x minus 3 times x minus 3. Well, that's an example of the zero product property because they are each equal to 0. If x equals 3 and negative 3, then those are our zeros. So that's the zero product property. And then from that point, they distributed everything. So they did the FOIL method. That's the distributive property. And then finally, they combined like terms, the negative 3x plus 3x there. So those are just the steps we took. Problem 4, finding the multiplicity of a 0. Multiplicity, that just means that a 0 shows up multiple times or many times. The same 0 many times. And that many times could be 2, 3, 4, whatever. The multiplicity itself is how many times it does show up. So it says, what's the zeros of the polynomial x to the third minus 4x squared plus 4x? What are their multiplicities and how does the graph behave at these zeros? So we're going to factor this first. If anytime you factor, again, you want to look for a common monomial. And if I look at every single term, I notice that they all have at least one x in them and no more. So I can take an x out of each one of those, and that gives me x times x squared minus 4x plus 4. And then I can factor this trinomial. I still have my x, and then that trinomial will factor into, well, x and x give me x squared, and I need factors of 4 that when I add them give me a negative 4. And that would be negative 2 and negative 2. Because negative 2 times negative 2 is positive 4, and negative 2 plus negative 2 is negative 4. So we've got two factors here that are identical, which are going to give us identical zeros. 16 says the factor x appears how many times? So the number 0 has a multiplicity of, so our factor, when we're talking about the factor x, we're talking about this guy, and we only have one of those. So it says the number 0, because if we were to solve for this, we would get x equals 0, x equals 2, and we'd get another x equals 2. So we only had one 0, so it has a multiplicity of 1. The factors x minus 2 appear 2 times, so the number 2, which are the zeros themselves, have a multiplicity of 2. That means that we had 2 of them in the problem. If I graph this, it says the graph looks close to, is either linear or quadratic at 0 and close to a linear or quadratic at 2. So kind of what this looks like here is, and here's a 2, is that it's going to come up here and then it's going to dip down like that. So as it goes through 0, it actually looks more linear, but as it goes by 2, it makes a little parabola there, and a parabola is a quadratic. That's what it's asking us. Okay, one last problem here. Problem 5, it says using a polynomial function to maximize volume. So here we have an application problem. It says the design of a mini digital box camera maximizes the volume while keeping the sum of the dimensions at most 4 inches. If the length must be 1.5 times the height, what is the maximum volume? So they make a little equation here of how to find volume. Volume is going to be the height times the length of the camera times the width of the camera. It told us that the length must be 1.5 times the height. So we're going to put 1.5 in here and just multiply all of this together. So for volume, we have 1.5, we're going to do the first two, x times 1.5x is 1.5x squared. And in the orange there, I'm going to multiply or distribute the negative, and you get 4 minus x minus 1.5x. So that's 1.5x squared times 4 minus 2.25, or not minus 2.25, minus 2.5 x, and I'm going to distribute that. So I get 1.5 x squared times 4, that's going to be 6x squared, minus, and then 1.5, let's see, times 2.5 is 3.75 x cubed. So that's what represents volume, is that polynomial. Okay, and then we have our volume equals 6x squared minus 3.75 x cubed. If we write that in standard form, that's going to be negative 3.75 x cubed plus 6x squared. So the leading term is negative 3.75 x cubed. So it's a negative with a degree of 2, or excuse me, a degree of 3. And so if it's negative, it's going to end going down, and so it's going to look like this first graph. Then it says use the maximum feature on your calculator to find the maximum volume is how many inches and what's the height. So our maximum point, if we're looking at this graph up here, is that value. So we want to know what the x and y coordinates are. The y is, the output is going to be our volume, and the x is going to be our height. And so we would graph that on a graphing calculator. So I end up with ordered pairs 1.067 and 2.28. The y coordinate is the 2.28, and the x coordinate is my 1.067. So the maximum, at that maximum, the highest point, or the highest hump on my graph gives me a volume of 2.28 inches cubed and a height of 1.067 inches. And then we can also use that to find our length and width if we wanted to. because the length is 1.5 times x, so we just substitute the 1.067 in for x, and the width was let's see if I can remember what that was. Well, anyway, the equation for the width, I don't want to go back because I don't want to erase what I have already, and that causes me to do that, but that was the part of the equation where it said 4 times something, and we would substitute a value in for that, and then it also would give us the width, and then we would have the dimensions. Alright, and the last one here, it says write a polynomial function h, that's its name, that has 3 and -5 as zeros of multiplicity 2. So that means the 3 shows up twice and the -5 shows up twice. It says the expressions x minus 3 and x plus 5 are or are not factors of the polynomial. They are factors because if I go backwards from 3 and -5, I'm going to get x minus 3 and x plus 5. But multiplicity of 2 means that I'm going to have 2 of each one. So I would have a polynomial function h of x equals, I'm going to have 2x minus 3's and 2x plus 5's. And it just said to write it in factored form, so you can just leave it like that. You don't have to multiply it out. Alright, one last thing here for your homework. You're going to do numbers 2 through 28, the evens, and 29 and 31. Okay, happy homework, and we'll talk about it on Wednesday if I had you in class on Monday, and Thursday if I have you in class on Tuesday.